Bragg number that you measure experimentally is 2.17 Kelvin, thereabouts. And so at least it's okay, it's within a reasonable ballpark, I guess, of what you might, what you actually measure experimentally in that case. Now, what about gases? So again, liquid superfluid helium is not a true Bose-Einstein condensate because of the fact you have these strong interactions. It's just really a liquid rather than a gas. And so to actually achieve an actual Bose-Einstein condensate in something where you have a relatively dilute gas of cold atoms that have integer spin, it turned out it was actually very difficult to do, and people had to do, particularly Carl Wyman and also Eric Cornell in Boulder, Colorado, had to use a combination of laser cooling and trapping together with a magnetic trap where you have some kind of evaporative cooling. And so you can see they're actually cooling these atoms all the way down to 170 nanokelvin, which is way the heck down there. And to be able to actually observe this thing, they actually use some kind of video imaging where you're looking at the distribution of these guys. And what happens, and by the way, the shape of the potential they use in their magnetic trap was a harmonic potential. And so what you expect is that if you cool it down enough, it'll be really smeared out, like at higher temperatures. The atoms, it's like a random thermal distribution in this harmonic potential, but if you cool it down below the Bose-Einstein temperature, then it starts to look like your Gaussian wave function. And so what they were able to see is that, wow, it really sharpened up. It starts to look like a nice, like in 2 dimensions, like a Gaussian wave function. And so that was the first the first experimental confirmation of Bose-Einstein condensation in 1995. I actually hosted Carl Wyman here at U of H a couple of times in the late 1990s, thereabouts. And then finally, I think it was in 2003 when they got the Nobel Prize for that. Oh, that's it. Okay, so I think that's probably enough to try to digest for today. So I might show some slides, maybe getting into, there's another chapter, but what I might do is I might show some slides to give you a little bit more feel for what happens in superconductivity, and maybe I'll try to describe some of the quantum properties about superconductivity, some of the phenomena here. Okay, in terms of deadlines, I would say, let's say maybe make the deadline for the first homework a week from Monday. So let's say whatever that is, I don't know what
you can take a sweet time at homework.
So next week's Monday, so we'll say 1 week from the next class, yeah, whatever that is.
The 12th.
The 12th? Oh, okay.
Oh, wait, no, 13th.
13th, okay.